Hello guys, so today I'm going to be doing integration by parts. So let's begin. So first of all, I wanted to start where if it is that we had, or I asked you to get the differential, so ddx, of two things, two different things, the products of two things. So if I had ddx of, well, in differentiation, we normally use u times v. So u times v, how to do this? Well, you know that this is a simple product rule, right? Now, what would this give us? So this would give us, we would normally take the u, and then multiply it by the derivative, so in this case dv by dx, and then we would add that to now the differential of u, which is du by dx, times v. Now if you don't remember this part, you should probably look over differentiation, but this is just the foundation of integration by parts. So in this case, the foundation so far, as you can see, is just the reverse of this process. So the foundation is that integration is the opposite of differentiation. So that means that if we took the integral of both sides, integral, well, these two things will cancel out, right? Because the integral of a differential, it cancels out. So what we're going to have is we're going to have the uv, or u times v, is equal to the integral of u dv by dx plus the integral of v du by dx. And their dx is after. I just kind of like to, well, not kind of, I just kind of forget to add them, to be honest. You don't do that though, because you lose a mark. And typically for integration by parts, what they do is they just ask you to take this part and transpose it to the front. So you're going to have the integral of u times dv by dx is equal to, well, if we move this around, uv minus the integral of v du by dx. I don't know if these dx's cancel out, to be honest, but I don't think so. So yeah. So this is the foundation of integration by parts. Cool. But you're probably wondering, like, I have no idea what this means. So if I ask you to find the integral of x times e to the x dx, now you'd probably try to do substitution or something, but you'd quickly find out that these things don't work. You need to integrate it by parts, and this is because we have, well, it's two different functions, like two completely different functions, and they cannot be multiplied together to get one function or anything like that. It can't be simplified at all. So in that case, we're going to have to use integration by parts. So anytime you see two things being multiplied together and you can't easily make them into one, think about it as integration by parts, especially in this form. So how do we do this? So we just kind of found the general formula, right? And we didn't even know that, but here's what you're going to have to do. You're going to have to try to get this into this form. So we're trying to get what we have here to be into this form. But let's focus on what we have here. So it has u times dv by dx. What does that mean? If these two things are to be equal, right? What does it mean? It means that we're going to select a value for u, then we're going to select a value for something that's already differentiated. So what does that mean? Well, here is a way we can do this. So we'll just say u, because we're going to have to find a value for this. We'll let u, in this case, in our example right here, equal to x. And now for dv by dx, because remember, we're trying to find a way to mirror this exact form, because that's how we're going to solve the question. We need to mirror the exact form, so we're going to have u is equal to x, and we say dv by dx is equal to e to the x. Now, in the rest of the formula, right, in the rest of the formula here, what do you notice? Well, you might notice that we are going to have u times v, but what do we have here? We have dv by dx. So if we're going to try to get back to v, we're going to then have to say we're going to have to then take the integral of this. So when we take the integral of dv by dx, we get is equal to, well, the integral of e to the x is just e to the x. And if we take the differential, because if you look over here, we're going to have to be able to differentiate du by dx, then du by dx is equal to 1. The differential of x is just 1. And so if you remember from the form, the integral of u dv by dx is equal to uv minus the integral of v du by dx. well, first of all, you should probably just swap this. This is the general formula for integration by parts. But now we notice that we have u, we have du by dx, we have dv by dx, and we have v. So now that we've just legit just put those in, all we have to do now is plug those values in. So u is x, so it means that if we put the integral of u, we're going to have the integral of x, dv by dx is e to the x, is equal to uv, so u in this case is u times v, v we know is e to the x, e to the x, minus the integral of, well, when we get to here now, because if you're following along, we did this, we just substituted in our values for u and v, or well dv by dx in this case, is equal to uv, which is this thing right here, because we got these values here, minus this part right here. So in this case, if it is that we have the integral of v du by dx, right, what is it that we can say? Well, we can say that we already have a value for v, and this is getting really messy really fast. Our value for v is e to the x times du by dx, which is just 1. The u by dx is right here. And we've actually just solved our integration by parts thing. It's supposed to have a dx here, but yeah. We've actually just kind of solved our integration by parts. What we do now is we just have to simplify. So this will give us integral of x times e to the x is equal to x e to the x minus, so now what's the integral of e to the x times 1? That's just the integral of e to the x. The integral of e to the x is just e to the x plus c, because remember this is unbounded integration, there are no limits, so we have to add plus c. And I guess you could factor this out some more, but you would have just found the answer. And what do you notice, right? You notice with the form, because when we put it back into that form, we get the original question as the left-hand side. You notice the original question was to find the integral of x times e to the x, and so we kind of get it back, right? Now you might be wondering, okay, so in this situation you put u as that and you put v as something else. How do I choose? So I saw this thing online where there's LIATE. So this is how you're going to choose u. How to choose u. So L stands for logs, I stands for inverse, A stands for algebra, T stands for trig, and E stands for exponents, like E. So virtually we're probably never ever going to use exponents as your u value. But yeah, so let's see what you do if I gave you something like the integral of x sine x dx. So if I told you to find the integral of x sine x dx, what's the first thing you're going to do? You're going to choose a u and you're going to choose a differential of v. So instead of using dv by dx, I'm going to use v prime. So we're going to have u and we're going to have v prime. Now we're looking at these two things that are being multiplied. And then we go back over to our table to compare. It's not really a table, but it's this thing. And we compare it. So we see that we have x and we have sine x. So x is algebra, you know, because you do a lot of linear algebra probably, so x is algebra. And then we see trigonometry, because sine x is trigonometry. So in this case, in the order, it's supposed to go from top to bottom. In this order, we are going to choose the first thing that we see. So in this case, the first thing we see is algebra. So we'll let our u equal to x, and we'll let our v prime equal to sine x. Now, in this case, we have to find u prime now. So u prime, the differential of x is just 1. And then we find v, which is by taking the integral of v prime. Take the integral of v prime, we're going to get what? So the integral of sine x is negative cos x, I believe. And then, now that we've done this, we've literally already gotten the answer. So just remember the standard format, that is integral of u times v is equal to uv minus the integral of v u prime dx. Remember this general formula. I'm using dashes now instead of writing dv by dx, just a safe space. Now in this case, let's just plug in what we have. So we have u is equal to x, so we're going to have the integral of x times v. Now v in this case is negative cos x. Oh, sorry, it's supposed to be v prime. I was wondering if I was going hard, as I was going getting a little lost right there. Yeah, so if we have x sine x should be equal to uv, which is x times negative cos x, minus the integral of v. Now v in this case is just negative cos x, so negative cos x times the differential of u, which is just 1, dx. Now always check right here, like I just made a very simple mistake, but always check to make sure this is the question that you're actually trying to solve. And yeah, so now we'll just write the next line. We're going to have the integral of x sine x is equal to negative x cos x. And so there's a negative sign in here. We can pull the negative sign out. It's going to be plus the integral of cos x dx. Now the integral of cos x is just sine x, so this is going to be sine x plus c. So it's going to be negative x cos x plus sine x plus c. Or you could put it in a different order, but that's pretty much how you do it. Let's try something a little bit more challenging. So what would you do if I asked you to find the integral of ln x dx? I'm going to have a sip of water while you probably try to think about something, but really just think about finding a way to make this make two numbers be multiplied out of this. Okay, so if you don't have any idea, just remember that any number multiplied by 1 is itself. So this is the same thing as saying the integral of 1 times ln x. It's a bit cheeky, yes, but I think it gets the job done, so that works. Now what else do we have to do? We have to remember or liate. Maybe if I say it enough, you'll probably remember it. So remember, this is logs. And I already wrote everything down, but you should probably remember what these are. But in this case, remember, this is to choose u. So in this case, I want you to use this, run down the list, and choose what u should be. If you said u should be ln x, you're correct. So in this case, u is equal to ln x, and we say v prime is equal to 1. Now if you take the integral of v prime, that's going to be the same thing as the integral of 1, and that is just x. Now if you take u prime, now what is the differential of ln x? Now this is, if it is that you have just moved from unit 1 to unit 2 pure math, you probably not know what the differential of ln x is, but it is just 1 over x. Cool. So now that we know this, we have actually kind of gotten the answer, as I said before. So remember, just remember that, oh, I just said remember, but remember the integral of u v prime is equal to uv minus the integral of u prime v. Now we just have to plug and chug, and we have our answer basically. So we're going to have the integral of ln x should be times 1, same thing, is equal to uv, which is ln x, times x, minus the integral of u prime, which is 1 over x, times v, which is x dx. So now we're going to have the integral of ln x should be equal to x ln x minus the integral of 1 dx. Now remember, these two things cancel out, and we just said the integral of 1 is in fact just x. So it's going to be equal to x ln x minus x plus c, and that is our answer. So I'm hoping that you have kind of understood so far what integration by parts is. You'll really need to get this down if you want a chance at, have a chance at reduction formula. This is very fundamental for the reduction formula. But yeah, this is pretty much all you have to know for integration by parts, and I will just end the video here. I'll be doing reduction formula soon, so if you just watch this video, reduction formula is pretty good to watch immediately after, because it's legitimately the exact sequel. It's not really a sequel, but it's really supposed to be done right after, in my opinion, when I was learning it. But yeah, that was integration by parts.